Today, we're going to be talking about the 3 events that have to do with extensions and all the different ways that we can do extensions. Plus, a little later on today, I have my head builder for the Mechanites here, Travis, who's going to show off the linear lift system that he's been working on, so you folks can see an example of what's out there. But just like with the chassis workshop, we're not going to go over just the more traditional methods in FTC. We're going to give you a very broad overview of what options you have when you want to do some sort of linear extension. So, our comic of the day, Calvin and Hobbes, we need more extension cords. I saw this and I'm like, yes. And of course, if it's true FTC, then those extension cords would be all bound up and, hopelessly tangled and all those kind of things. So things to remember about. Okay, so lifting and reaching. A very common challenge in FTC games is for robots to reach or lift objects. In fact, I'm struggling to think of a game where reaching and lifting things wasn't part of the game. I don't know if some of the folks that have been around longer than I have can think of one. I can't. The example I have here is Relic Recovery, where they had to pick up that idol and move it outside of the field. Robotics, of course, you picked up the minerals is I think what they called it, the little balls and cubes, and they put it up into a receptor. Not to mention the robot hung itself from a hook at the end. Skystone, obviously, you picked up and stacked the blocks. And this year, even though this year didn't use linear lifts as much as maybe some other years, you still had to pick up and move the wobble goal, okay, outside of there. So even though this year was pretty light on lifting and reaching things, although I find that there's balance in these things. So because this year was really light on these things, and since we know that the balls and cubes are coming back, there's a pretty high likelihood that you're going to have to pick up and move those objects next year. So not a bad time to start thinking about how you're going to move those things. So a lot of the time, the robot needs to be able to lift itself, okay? So like what we have with Rover Ruckus. During this workshop, we're going to go over multiple ways for the robot to extend itself beyond its 18 by 18 by 18 starting size. So here we go. This one is one of the ones that you'll see a lot of rookie teams do, just because this is part of the build guide that comes with both Rev and Tetrix basic kits. Easy way to pick up things is just to build an arm. So this is what I'll call a simple arm. And this particular example, this is the Rev Education Bot, is what they're calling it. And you can see it has a motor up here that meshes with a gear that is attached to an arm that simply moves that arm up and down. Tetrix has a very similar kind of arm system to it. When I was a rookie coach with that team, we had a Tetrix bot and we had the basic arm on it. This was for Rover Ruckus. Pretty easy to build. You can do a single gear, or if you really want to, you can do multiple gears to adjust the exact distance or gear ratio, or you don't even need to use gears. You could use belts, you could use chains. There's all, you could use a lot of the methods that we've talked about with transferring power from chassis. And usually the end of this has some sort of claw or gripper or other intake system. This is more of a passive intake, which we'll discuss more about later. The pros for this is it's pretty quick and easy to build. Okay, so if you've got a team that's just barely learning how to figure things out, an arm, a simple arm, might be appealing to a lot of these teams just because you can knock it out in a single afternoon. Pretty simple to build, pretty simple to program. However, this has some pretty serious cons. The big one being limited reach. Because you have to have your simple arm fit in the box, that means your simple arm can be at most 18 inches and usually shorter than that because you've got to have the entire thing fit in that box. So often you can only get, maybe 12 to 14 inches of extension. These kind of arms also require more torque. Now think about it. If you've got a weight, like let's say that this controller was a heavy weight, is it easier to lift that heavy weight straight up and down? Or what about if you put it at arm's length and lift it like this? Think about it. When you're putting what you're lifting all the way on the end of that arm, it requires more torque. It's part of the form, if any of you have taken physics, part of the formula for torque is the length of the arm. And the longer the arm is, the more torque it requires to lift an object. So you've got limited reach, it requires more torque, and these kind of arms can be hard to control. Particularly if you're not using motor encoders. So there are ways to get around it. You can do some programming tricks, particularly with motors that have built-in encoders, that with a button press, you can have it move to a specific position. And if you're going to use a simple arm, I would strongly recommend that you have something like that, either using the encoders or having some sort of switch or other way that you can control it. Because otherwise, these things can be more difficult to control than they seem. Now, has anyone here used a simple arm on a robot and want to talk about their experience? Not really? I mean, that's fair. I mean, a lot of teams, once they learn that there are other options, usually move away from the simple arm. So you don't see it a whole lot, although sometimes you'll see it in FTC, but you won't see it as often as a lot of the other systems. Okay, another way you can use an arm is what's called a chain bar arm. Okay, this allows for multiple segments on your arm. And essentially you bolt a chain to a bar. Okay, and that bar could be a rev extrusion, it could be a piece of channel. And what this allows is it allows you to hook multiple bars together, and it allows you to keep your orientation of usually the end of your system parallel to the ground. So in the case of this is again from Relic Recovery. This claw remains the same distance from the ground, whether or not it's fully extended, halfway extended, or even, fully contracted. And that's a lot of the idea of this. When you're picking up an object that has a set height, like this idol, this makes it easier to control where it is and not having to do more complex, calculations on that. So this kind of system could work really well for things like Relic Recovery. Or if you're thinking about our events, one of the events we have is the grabbing of the ring, right? Off of a peg. And so if you want to make sure that you're grabbing at the same elevation using an arm, a chain bar arm is one way you could do it. Just because that chain bar will make sure that it's at the same distance from the ground, no matter how far you're extended. So some pros, One is this allows you to go beyond the 12 or 13 inches that you get from a simple arm and allows you to reach a little bit farther. However, you've got a lot more control problems with the chain bar arm just because it has more mass often, and more at mass means more momentum, which means more finicky movements. And like the regular arm, even more so than the regular arm, because again, you're extending the arm, which means when you extend the arm, that means it requires more torque. Now, for something like this very, very light idle, that doesn't matter as much. But if you're lifting something that has any weight to it, this system is going to need a very high torque motor to be able to lift anything. So that's something that you have to keep in mind. Of course, you can use some of the same programming tricks as I mentioned before, using either encoders or switches so that it automatically moves to a particular position. So there are ways around it, but you have to take these things into account when designing this. I see we've got a few more folks that have popped in. One of them, of course, is one of our great partners in crime, Nicholas Macy, our head ref for this last year. And also one of the people I always ask for his opinion on these kind of things because of his extensive experience in FTC. So does anyone, including Macy, does anyone have any experience with using a chain bar arm? I want to talk about that. I don't know if I've ever seen this one in Utah. I can't think of any. Kirby, have you ever seen a chain bar arm like this at competition?
I don't think I have.
Okay.
I've seen one or two.
You've seen one or two? Okay.
Yeah. It's typically not used a whole lot because by the time you get the amount of controls you want on it, you're using quite a few motors or circuits.
Yeah. Yeah, that's
and like you were mentioning with it being, because essentially the way that it works is it's a lever, right? So you have a lever on a sprocket, and so you use the chain to help control that lever. But it becomes very unwieldy at speed, and it becomes very difficult for finesse. So
yeah.
It's one of those designs that it's typically, where I've seen it is like with relic recovery, or where other things where it's a very simple preload and we're just flinging it out to a destination. So we actually had, I think, 2 different robots this year, this last season, that had that because they could preload and then they would just fling it out. So.
Okay. Got a comment from the chat. It says you might be able to fling it up over the lift bar like a grapple to lift up. Yeah, and yeah, technically you could. I don't know if I'd recommend that though. So okay. Now for really complicated arms, you could use multi-axis arms like this guy right here. This is an example from Game Manual 0. So multi-axis arms uses multiple sections and points of rotation to do more complicated motions. Now, an important point to mention is a lot of the material or the arms and mechanisms that we're talking about today, you could buy commercially off the shelf. A multi-axis arm is one of those things that you cannot. The reason why is because in FTC, you are limited to off-the-shelf parts can only have 1 degree of freedom in motion. So it can only go forward and back. You can't have a commercially you can't use, a commercially off-the-shelf system that has more than 1 degree of freedom. That doesn't mean you can't build one yourself. You can. But you can't have a pre-built arm that has multiple degrees of freedom to it. So multi-axis arms like these can do multiple rotations and points of rotation to do more complicated motions. A year ago, I was actually invited to be an online judge for MTI at Maryland because they did that all virtually. And one of the teams had put together a very cool looking multi-axis arm. And one of the things they were able to do, so suppose that this is a Skystone block, because one of the problems with Skystone that a lot of teams ran into is a lot of those intakes were only designed to pick up the block if it was already upright in the right thing. Well, what happens if your block's on its side, if it's fallen over or something? A lot of robots didn't have a way to deal with that. And so this robot could actually pick up the block and rotate it like this to the correct orientation, and we're able to stack it like that. It was a really neat but very complicated. That was from a Chinese team, as I recall, that had designed that arm themselves. So the nice thing about multi-axis arms is they're extremely versatile, and they allow motions that just simply aren't possible for a lot of the other systems that we're talking about today. However, as neat as this is, most FTC motions don't require anything anywhere near this complicated. Picking up and twisting objects is not something that we usually do in FTC. And in order to properly move this multi-axis arm requires something like kinematics. It requires a more advanced algorithm or software to make sure that you're getting all of the angles correct, so that, because the thing is, when you're picking up an object, for example, you're thinking about where the end of the arm needs to be. But when you're using a multi-axis arm, in order to get the end of the arm where it needs to be, you need to think about all of the diverse angles that are required to line it up in the right place. And I would say that for the vast majority of situations in FTC, a multi-axis arm requires, it's, and also you need to have, motors or servos in all of those joints. It's a pretty big undertaking to take on. And there are very few cases where taking on that undertaking is worth the added benefit in FTC. So, Nick, do you have any additional thoughts on that, or things that you've seen maybe at FTC or FRC?
Not a lot of teams spend the time, right? Because one of the things you all need to kind of keep in mind is, it's like, if time wasn't a factor, you could have the greatest robot ever created. But an unfortunate thing is that we all have a limitation of time. And so when you look at like a multi-axis arm, like, they're fantastic and they can do so much, but you have a finite resource of time. So is spending all of the time necessary to create your own multi-axis arm that has multiple failure points something that is worth it? Or can you create a far simpler, more reliable mechanism that will accomplish the same task and it will be shorter for you to create? Like, the great thing about FTC is the fact that there is 1,000 ways to solve every problem, if not more. And so it's finding your own unique combination for that, for it to work for how you do it. And there's an old adage of keep it simple, stupid. And honestly, that goes a long way, because the thing is like, when it comes to competition, your robot has to perform for 2 minutes exactly as designed and performed. That's very little leeway. And on top of that is you have to be able to repeat that within 5 minutes. So if something breaks in that 2-minute period, you have 5 minutes to fix it. If it's a complicated multi-axis arm, you're probably not going to be able to figure out what's wrong with it in 5 minutes. or if you are able to figure out what's wrong with it, you probably are not able to replace that in 5 minutes. And so it becomes, okay, it becomes a time issue of we have to now create our own multi-axis arm. On top of that, we need to test it. On top of testing it, we need to identify all of the weak points. And then we need to have a repair plan created so that if something goes wrong during competition, or arguably when something goes wrong during competition, you have a quick fix to be able to repair that and get it going again. And that takes a lot of time. Whereas, because essentially you're creating 3 or 4 arms or mechanisms. And it's like, okay, so if I create 1 versus creating 4, what is the reliability of 1 versus 4 different objects? And if 1 object fails, I still have 3 other objects that are working. So is that more detrimental, or is that a better thing? Because this also goes into what is your strategy? Are you building 1 arm that can do all of the tasks? Okay, great. If 1 arm fails, you can't do any of the tasks anymore. How does that play out in your strategy? Versus having other arms that are specific for each task. If one of those fails, you only lose 1 task. So as you kind of look at these different contraptions, because this is information that's applicable to all of the arms. We have a great example here with the multi-axis that, hey, this is really complicated and thus difficult. And you had the one right before with chain bar. Well, that's really simple. There's not a lot to it. It could definitely be used for certain mechanisms, and maybe that's what you do is you make it for a purpose-built mechanism. But the utilitarian of it, right, the utilization of it for multiple things could also outweigh those risks if you are trying to accomplish things. So this all comes down to strategy, what your strengths are, what your weaknesses are, what can you accomplish within the time that you have.
And I would say for this week, or for the summer's 3, events that have to do with extensions, none of the 3 would make sense to use a multi-axis farm given the time that you folks have. So I'll mention that as well. Okay, now let's talk about linear motion, which is one of the more common ways to do here. So one of the most common ways for a robot to reach out in a straight line, either horizontally or vertically, or even at an angle if you really want to, is to transform the spinning motion. Because think about it, all of the FTC legal motors spin. And so in order for a robot to reach, you have to transform that spinning motion into linear motion. Now, there's not just one way to do this, okay? The way that probably came to most of our minds here just now is the drawer slides, which we'll get to in just a moment. But again, one of the purposes of this workshop is to give you a sampler of what kind of other options there are available to you. Okay, so one way you can do this, we won't get to the rigging and things right now. We're just going to talk about the system here. So one way to do it is just to use common drawer slides that you can get at any hardware store. So you can run to Lowe's or even Walmart, I think, or something, or you could buy them from Amazon. Is you can just get the common old drawer slide. And one of the nice things about drawer slides is drawer slides have been around for a long time. They've been optimized very, very well for what they do. Now, a lot of drawer slides that are available out there, particularly the common ones, are made out of steel. Now, the nice thing about steel is it's a hard metal. It's pretty durable. The parts in there are durable. The downside to steel is that it's heavy. So if you think about having a bunch of steel drawer slides being lifted up on, say, a cascading lift, you're going to need a higher torque motor to lift those drawer slides than you would for something that was a little lighter, like something made out of aluminum, like the aluminum drawer slides we'll get to, or aluminum extrusions. So again, as we've discussed with the chassis workshop, there's trade-offs in all of these things. yes, you're getting higher durability, but you're also having to deal with the heavier weight. The other thing about drawer slides that you need to be aware, at least the common drawer slides, is you're probably going to have to modify them in order to make them fit your system. Sometimes you can get lucky and the holes are in the exact place where you need them, which in that case, great. I will say that a lot of the people that I've talked to that use common drawer slides, they've had to drill into these things to make holes. And guess what? It's steel. Steel is hard. It's certainly not impossible to drill through. And if you have the right bit and the right tools, it can be fairly easy to drill through, but you have to take that into mind. You might need to drill into this to place these together. So these do take some modifications, but these are a really, really common and really useful option in FTC to do any sort of linear motion. And again, we'll get to the pulleys and the rigging on this a little later on. But yeah, this is a perfectly fine and even great way to do linear motion. I think there's a few teams. I think I talked to the master or the coach of the Masters yesterday about using linear drawer slides, although I wonder if that was the older team rather than the ones that are here now. But does anyone want to talk about their experiences?
So yes, my team used it for rover workers to hang. And yes, all those kids have graduated. They're not on the team anymore.
Yeah.
But yes, definitely lots of drilling, lots of modification. We had to go buy new bits because to drill in the steel, the bits we had didn't work.
Just so old.
They worked.
Yep.
And it was cheap. I think they were like $15 at Home Depot for like 2 drawer slides or something like that. So
yeah, it's a really inexpensive option. Anyone else have anything to share about their use of drawer slides, the common ones? Okay, got a ping. Okay, IKEA, yes. You could go to IKEA and get drawer slides. And they work just fine. Let's see, another thing from the chat. Yeah, super duper cheap. Yeah, absolutely. So if budget is a factor in choosing your system, rather than shelling out money, quite a more money for like a kit or for some of these other things, yeah, that's one of the wonderful things about FTC is you don't have to. You can use a inexpensive system like this, and as long as you're willing to modify it, it's a great option. Now, another option that's a bit newer is the more specialized aluminum drawer slides. So some companies have started to make drawer slides with FTC specifically in mind. The example I have here is a company called Robotics. This is a company that was founded by alumni from FTC, and they partnered with other companies to design and manufacture drawer slides that are built with, our competition in mind, which is really, really nice. Some of the key differences between this and your average drawer slide, one is these slides are made out of aluminum, so they're considerably lighter. And then the way they work is they have aluminum ball bearings inside, and that's what allows the drawer to slide. So the outside's made out of aluminum. The ball bearings, though, I believe are steel, as I recall, which that can be a problem with wear and tear, as we'll talk about later. So Robotics has actually gone through and designed a full system with 3D printed inserts in the middle that just allow you to essentially adapt to whatever system you have. We've used this system with both Go Builda parts and Rev parts. I haven't tried it with TETRICS, so I can't speak to that. Although I think you can still use this system with that, although you might need to modify it. You might need to move the holes a little bit. So both Long Robotics and Misumi is the name of the other company, although Misumi was not an alumni. It just so happens that their drawer slides really work really well with typical FTC systems without the need for a lot of modification. So, and the thing is, these can go really quick. If you folks remember Skystone, you can remember teams like Checkmate, which Checkmate I think used Misumi's, as I recall. You could watch how when they were stacking blocks, they could move up and down very, very quickly when they were stacking the blocks. And part of the reason why is because these are really, really low friction options. And so it allows teams to really pop up and down very, very quickly. And in fact, you can, I've read websites with Long Robotics as I was doing research for using them. This is actually what my team uses, this is the Long Robotics system, is that you can even essentially take out the grease in there to make it even more, even quicker to move up and down. Of course, you're sacrificing some of your durability and they're probably going to wear out faster if you do that. But again, it depends on what the application is and how willing you are to lessen the lifetime of something to get it to work in an optimized way for a very specific game like Skystone. So the pros are they're light because they're aluminum, they're smooth, they're easier to adapt to current FTC build systems, and they're excellent for lifting particularly light objects very quickly. Now, these are not going to be as cheap as just running to IKEA and picking up a bunch of drawer slides or even to Home Depot or anywhere else. I think they were, I want to say like $16 each, if I recall. Kirby, would you mind just hopping onto the Long Robotics website and see how much these folks were? I mean, they're not break the bank expensive. Although, if you think about how many stages you're going to do, particularly for a game like Skystone, it's going, you know, that's going to add up over time. But they're not like $100 a pop either. They're not so expensive that it's just impractical to be able to, for most teams to use. They're fairly okay as far as.
So for these slides, I'm seeing $16.73 each, or a 6-pack for $88.
Yeah, so you can get them. Yeah, if you buy packs, which that's what we ended up doing, you can get them for a discount. Okay, so the Mechanites, which is the team I coach, uses the Long Robotics slide. And we thought for this workshop, it would be a good idea to have one of the folks on my team, my lead builder, Travis, kind of demonstrate how they work and for him to talk through the process that he's gone through in using this. So I'm actually going to stop sharing my screen. I'm going to allow him to share his, and he's going to talk about kind of what he's used here. So I'll turn the time over to him.
All right, so I'm not going over just the linear slides or whatever. I'm also going over some other stuff for some rookie teams or some other systems, if you want to know that kind of stuff. So first off, we have servo parts, and this is for like those small arms or grabbers that you would want to use. Generally speaking, you're going to want to use a strong servo, so like a 12-gram servo or basically something like the Rev Smart Robot Servo, which I have a picture of it here. And also here we have, this is a special part that Rev came out with a little while ago. And it's meant specifically for building these arms with their Rev extrusion here. And the nice thing about this is that it's really easy to take this on and off. It's just like you loosen this bolt, slide off that, and then you can tighten this bolt or take it off. It's really nice. And the nice thing is that it's full metal, so it's not going to break on you or anything like that. And one of the pros about using the Rev servos is that Rev actually provides spare parts that you can get for it. So if your gears strip inside of the servo here, they actually have a gear replacement kit that they have on their website. I don't remember the price off the top of my head. I just saw it on a glance. Another thing that you want to do is you want to make sure that the servo mounting plate is a strong plate. So originally I had just one metal plate here, but that started to bend with this arm. And so I actually had to add on another plate here, and that fixed that problem like tremendously. And now the arm does not like wobble all over the place when you're driving around, which is really nice. I'm going to demonstrate all of this on my robot after I'm done with the presentation. So, all right. And then this here is a rookie grabber arm. And this is actually based on a Skystone grabber and arm. And there was a lot of teams, like top teams, that use this kind of system for their autonomous. Because for Skystone, they had these blocks with pictures on it. And so you can drive up to them with a camera. And then if the camera sees the block, it will put down this arm here, and then it will grab the block, pick it back up, and then drive it back across the line. And this system was really fast for that kind of thing. And this kind of system, you can adapt to a lot of things. On the other side of this bar here, you could just put on 2 bars that come out like that, and it can pick up spheres. So like for next year's game, when you're picking up those orbs from Rover Ruckus, you could do that kind of system, or you can use this for cubes as well. And basically you just need to move this servo mount here back in like that. And something else that you want to do for this kind of thing is you're going to want the servo to go like a little bit farther than you would want it to usually go. So like, let's just say your block's like this. So instead of having the servo go up against it flat, you want it to, so like, basically you want it so like if you were to put it like normally, if you're just like a sketch kind of a thing or whatever, like it would, that the servo arm would be going inside of it. But since the servo arm can't actually go inside of it, it will just pin it against, so that it will have a much better grip against the block. Something else that I would suggest as well is using tape here. Like I use some duct tape here, and this is like 3 or 4 layers of duct tape just wrapped around these bars here. And the nice thing about that is that it acts as like a rubber kind of thing. And basically what it does is that when it comes in and grabs something, the tape compresses, and it just kind of acts as like a rubber kind of grip sort of thing. And so that kind of thing is like really nice to have, so it'll hold your blocks really well. And then this here is linear motion. So this is another version of just kind of going like straight across like this instead of going up and down. So like for Rover Ruckus, when you're trying to get stuff out of the mineral pits and then bring them up to the lander, usually teams would be sitting outside the mineral pit and it shoot out an arm with a intake system, then we'll pull it back in, drop it into a linear lift system, which will shoot up and then drop it in, like that kind of system. And so there's a couple of versions here. This one's generally not too many teams use this because it's a little bit more of a clunky system, because you usually use like a lead screw and then you attach something to this little thing that sits on there. And then as the motor turns, it pushes this up or pushes it down. And it's pretty decent for getting like very precise movements. but at the same time, it's not too worth it because usually these lead rods are really expensive. Like I do 3D printing a lot and they use lead rods and stuff for that. And those things are pretty expensive, like 30, 40 bucks for one of those kinds of things. And so it's like not too worth it necessarily. And another problem is mounting it to the motor, because there isn't like holes that you can thread and then just put a screw into it and attach it directly to your frame. You have to attach it directly to the motor. And basically it's just going to be free hanging essentially. And so it's not going to be the very best. Although there was one team from Park City that used this kind of system. It was Robominers. And during their Skystone season, I think it was, they had this where their robot, like, so basically they had their chassis and then in the middle, they had these lead screws. And then the top of their robot could slide back and forth like this. And it wasn't too useful, but I mean, it was pretty cool to see that kind of a thing. And then here is basically the same thing as this. These ones are going to be the easier ones to do. Basically, this rubber wheel here, you're going to put a motor into that. And then with this, you're going to just put like a shaft through it. And basically, it's just going to move this bar right here back and forth. And this is really nice because basically this bar here could be like 18 inches long, or you can stack them on top of each other to make them like longer or whatever. But the nice thing is that this thing could go in and out just fine, and it's not too hard to do. Here's this one, basically does the exact same thing, as well as this one. Now, something that's unique is that GoBuilda has also made these linear servos. And these things are actually really expensive. I think the cheapest one was like 30 bucks, and that was like the really short one because this is actually not that big. And these things are nice because it gives you really precise movements, and they are pretty easy to mount on. And so they are pretty nice, but you're not going to be able to hold a lot of weight with these kinds of things. So that's one downside of it. Right. And so here's our systems that are made for this, just for this presentation or whatever. So I'm going to go over kind of building these slides here. So this right here is the diagram that Peevler used. And basically the nice thing about this is that they have 3D printed, these inserts here that are 3D printed. And the nice thing about these is that it holds the slide really well with this here. And also they come with these nice bearings here that you could just loop your string over, which is really nice. And the nice thing is that they're 3D printed, so you can actually cut them down like this one right here. Because usually if you have it come up like this, you usually have to have your motor right here, and then that's where the slide will go to. But since I didn't want to have a motor that high up, and it's a lot harder to mount a motor sturdy up there, I decided to add this little bit in and have the motor down here lower to the frame. And so I did that. I just basically cut off one of these little slide bits here. And another nice thing is that since they are 3D printed, you don't have to wait for them to ship to you. You could just 3D print them. You can have a whole lot of them at your disposal, and you can 3D print in like a whole lot of different materials. Like you got PLA, which we actually use a lot. You got PETG, which is basically a stronger kind of PLA. And then you also have carbon fiber, which that one's probably going to be one of the best materials that you can use. The only thing is that that filament's really expensive because it's carbon fiber. So anyway, so just going over the main of this. So we have a motor here and a pulley, and basically that's attached to this paracord essentially. And you have to make sure that you string it right, and it's a lot easier to start from the motor than it is to start from the end. So you just kind of come up here, then go over, then you go through, and then you bring it back up, and you just kind of do that over and over again for each part. And then at the end here, I just put it over here and then attached it to this rev extrusion that I have. And I just attach the string straight to that. And yeah, these screws that are using, they give you these screws, I think, if you buy the pack. And these are countersunk Torx bit screws. Nice thing is that these things, they don't fall out like hardly ever, which is really nice. And another thing is that these screws here are actually the same size as the GoBuilda screws or whatever. So like they're basic, I think M3 screws. And the nice thing is that then you can combine those kinds of parts really well. And so the way that we did it is we actually, so like right about right here, we have this channel connector from GoBuilda, and we put that on there and then put a GoBuilda screw through it. And since it's the same threading, it just goes straight through, connects down to here to this slide. And then we get a rev extrusion like right here, and we put it along the side that doesn't have the bearings on it. And so it actually is able to fit half of it's like on this insert kind of thing here. And then the other half is actually outside of it. And so it sits there, it's really secure, and you just put 2 screws here on each of the little GoBuilda parts. And it holds it very secure. And since it is the rev extrusion, it's really easy to add other parts onto there and whatnot, which is really nice. And then motor and cord or whatever. So also with these kinds of slides, you can use them to move horizontally as well. The problem is that these kinds of slides, they use gravity to pull them back down. That's why they usually only go up. So something that you could do is you could use something like the surgical tubing from Rev. And we use this for, we have this on our robot right now, just for cord management. I'll go over that later. But the nice thing is that this kind of stuff is like really stretchy. It's basically like a giant rubber band. And you could attach it to the one end of the, so you could attach it to basically the beginning of this and then the end of the last slide. And basically what they'll do is that it will pull the slide back in. So it'll act as its own gravity sort of thing. And the next thing is that you want strong string. So this string here is from Rev. We didn't use this. We just went to like a hobby store and got some paracord string, which has been working pretty well. It did snap once during competition, which I think was state, but it was like the last match. It's so yeah. And so we haven't tested out the Rev stuff, but I assume it's really good because they sell this specifically for lift systems, and it's only like $2 or whatever, and you get like 3 meters of cord, and so you get like plenty. And same with this tubing here, I think it's like $3 or so, and you get like 3 meters of tubing. And then choosing your motor, we like using the Rev Ultraplanetary motors because you could change out their gearboxes really easily, so you can get exactly what gear ratio you need. So you could get a good combination of speed and torque. So here I have a 5-to-1 gearbox and a 4-to-1 gearbox. And basically if you put those together, it'll be a 20-to-1 kind of setup. And so basically this system here is running on 20-to-1. And a way that you can test out to see if your motor is actually good enough is that you can wind up the string on the pulley and wind it up all the way to the fullest extent. And then if the slide goes down and the string is coming up like that, you know, and the pulley is like unwinding, and that's when you know that you're going to need a stronger motor. And so, and I can also hear differences between when the motor is struggling and when it isn't. And so something that I found is that I should have probably put in another 5-to-1, so it would have been a 25-to-1, and that would have made it a little bit better because once it goes to the last stage here, I can hear the motor really struggling to pull all that weight up. And you want something where it will have no problem, like you don't hear any difference in the motor sound when it's going up, when it's like pulling up itself, because usually you're going to have, sorry, you're going to have something like the servo here that has this little arm that's going to be like grabbing something and lifting something up. Like this here is actually our wobble grabber, and then I added on another slide because I was like, yeah, why not? We have parts, it'll look cooler because it'll go taller. And so I actually put that on, and so yeah, and so like we use this to lift up the wobble goal over the wall for last year, and this system worked really well. It was actually the most reliable part of our robot, the entire competition, which was really nice. And it was something that I threw together in one night, and it's just works perfectly. So that's another part about it, is that they're really simple to throw together and just get like a system basically laid out, and then you could just pretty much throw it onto your robot and just program a few things, and then you're done. And it's not going to really do anything, so it's really nice. And then cord management. So this is it fully extended. So I used this. So with the chain, I didn't use the chain here because the thing with the chain is that it's basically, it folds out so it's straight, but then as it goes back in, it becomes like this, basically this really long bar that sticks out. And so once you start getting into higher and higher areas like this, the chain's going to start sticking out the front of your robot. Like I was going to use this because this is what we used on our robot last year, and it basically went across the entire top of the robot. And when I put it on for the full 3-stage here, it actually went from here all the way out to like right about here. And so I was like, oh, I'm not going to do that because I want to show it like the robot as like a field legal kind of robot. And so instead, I actually use this chain wrap kind of a thing. And basically all it does is just hold the cords together, and then it's just basically like this little plastic wrap kind of a thing that just goes around the cords. And to keep it from tangling, I actually use that the Rev surgical tubing, and I just tied it to the middle, and then I tied it down here to the chassis. And the nice thing is that when the slide comes down, this tubing here just pulls it down into it. And so this tubing is actually just pulled down, and it just keeps all the cords out of the way, which is really nice, but yet it could fully extend and have plenty of space. So the cords aren't being pulled out or anything like that. So that's something that's really nice. And the nice thing about this is that it's a really thin plastic, so you can just cut it with scissors if you don't like the length. Or if it's too short, you can actually just tape them together. This is what I did here because we didn't have a long enough one to go all the way down. So I just used 3 smaller ones, and I just taped them together. And that works really well. All right. And all the grab. And so the nice thing about 3D printing this kind of stuff is that it's going to fit like the exact size that you're going to need, or it's going to be able to basically get to exactly what you want it to be. So like with building it out of metal, like the rookie wobble grabber I have here, that it's a little bit harder to get really precise objects like a wobble like shaft that it has. It's really hard to for you to build something that will grab that securely. There are ways, but I mean, at the same time, it's going to be a little bit easier just to 3D print it. And so we 3D printed this here, and I used Fusion 360 to make this, and it worked really well. It never broke on us, which was really nice. And also another thing is that the 3D print ones look a lot more professional, and the judges like seeing you using CAD on stuff. And so I'm actually going to pop over to Fusion, and I'm actually going to show you guys the basics of kind of like making a grabber sort of a thing. So I'm going to go off of like the wobble goal stuff. And so usually what I'll do is I'll make a sketch, click on the bottom here. And then what I'll do is I'll make a circle, and I'll go out like that. then I'll hop over here. And then if I go here to the ultimate goal, or well, just the game manual too, they have the sizes and stuff all the way down here at the bottom. And so you can see the actual shaft dimensions and stuff here. So this is a 1-inch diameter shaft here. So if I go back here, do 1 inch, and that's the shaft area there. Then what you can do is you can basically just go like this, like that, and then just cut out that bit there. And then you can finish the sketch, and you press on this, and you can press extrude, and you can bring it up like that. And basically what this will do is now you have this on a row here, and then you can just have like a little grabber or something, and it'll just pin the wobble goal against this, and it just holds it really well and very securely. So it's kind of like our wobble goal grabber kind of a thing. And this is like, you can just do this and then print it, test it out, just kind of try fitting it in places, and just kind of seeing how everything fits. Let's see here. Because okay. So I have some multiple versions of the wobble goal grabber that we made. So this is the first one that I made here. And this one was just a really easy like test print here. So I could slide in the servo here, and then I could basically just test it, grabbing the wobble goal, see how reliably it could grab it or whatever. Then I pretty much redid the design in 2 different versions. And here's the first one. This one was more for the rev extrusion. We didn't actually print this one out because we're just like, don't necessarily need it. And this one, we didn't really test it out. The hardest part about mounting these kinds of things though is getting the mounting stuff correct. So that's always going to be the hardest, and like getting like the screw alignments and stuff, that's always going to be hard. But yeah, and then here's the other one that I made. Load. Okay. And basically this one is more like the design that we have currently on our robot. And so we basically have this little thing that sticks up, and then the 2 holes here. And you basically just put the screws into there, attach it to the rev extrusion. And then you put the servo here, you have a little arm that comes in, just kind of grabs the object or whatever. And so it's just really easy to make these kinds of things, because you just basically measure the dimensions usually, and then you just go into a sketch and then just create like a little square or a circle of the like dimensions of it. And then basically from there, you just edit it a little bit here and there, cut off little bits, put in holes, just get it kind of like where you need it to be. So let's see here. It's like with the servo, you can just like look at the dimensions of the servo itself. And then if you want to, you could build something. So like just go like this. Let's just say this is the dimension of the servo. And then just go out like a little bit. And then let's see. So yeah, just go out a little bit like that. And then basically this is where the servo will sit. And then you could pretty much just do this. Oh, wait.
So while you're putting that together, one thing I'll mention is that Fusion 360, particularly if you've got people in high school, which FTC or middle school, you can get this software for free to use. So this isn't something that you have to shell out a whole bunch of money for. This is a resource that you can use for free. And now there are other programs. You don't have to use Fusion 360 per se, but there's a lot of free options to learn how to use these kind of softwares. to do your 3D printing and things like that. Something that's, and one of the things, I'll admit that this is something that I'm not as strong with as some of the other things, but one of the things I've been impressed with on this demo is how simple you're making this look. Or a lot of these different things that you can deal a lot with, that kind of. Macy recommends. I always like to recommend Inventor. But it's more in every way than Fusion. Fusion's a great starting place. Yep. So
Yeah.
I just want to say we use Onshape because we used to have Fusion, but we didn't have enough computer that could run it. So with Onshape being web-based, everybody can use it no matter how great their computers are or not.
Right. A lot of great options out there.
And Onshape is free too. So.
And then Macy recommends that Inventor can run stress analysis. So how easily your materials would be to break.
Yeah.
And there is a Fusion 360 web thing as well.
Yeah. So. You could do that for Fusion as well. I'm not too advanced in Fusion. Like a lot of the stuff that I do here is really simple stuff, like editing STL files or changing the file format on a file or something like that. Like I had to do that for the long robotics slides. And so basically what I did is I imported them into here, then I exported them as a STL file. And that way my printing software could read it. Because the way that you get it from their website is a step file. And my slicer can't read that. I don't think very many slicers can read that. And so it's just probably going to be a better bet just to upload it into something, then export it as an STL file. Then that way you'll be for sure working in your slicer. And so like with this here now, I can just select all these faces here. And then I can extrude it like that. And then if I extend both of these sides here, or never mind, forget. Well, anyways, but if you get this right, then you can basically just slide your screw into here and then put the screws into there. This right here isn't really precise at all. I don't think the servo will actually fit in this, but this is just like an idea kind of a thing that you can do. And then basically you could just build this off of that or whatever. And it's really easy to do with this kind of thing. And yeah, it's like with these wobble go grabbers I made, they're not too bad. Like it only took me like a couple days or so to get them to like where I wanted it to be. Something else that I do kind of like about this is that you could play a video of you building it. So just watch this one. So this kind of shows you like the different steps and versions that I kind of did with it or whatever. And then another thing that you want to do is you want to make sure that you don't have these little like overhangs like this, because that's going to cause the print to not print quite as well. And because you want to print it so it's like flat like this, you know. So this is just me editing it, just getting it right, whatever. And then, yeah, so that's like that build right there. And so it's like pretty simple. You can kind of see what I was doing. It's mostly just like making shapes, extending them, then doing another drawing, building off that. It's kind of just doing that sort of thing. It's like pretty simple. Like when people think of CAD, they think of like making like really precise big things, like making a very exact model of a car or something like that, or an inch and block or something like that. But it doesn't actually have to be necessarily like that. It can be just like a general thing, so it like fits to the point where it will work or whatever. And something that you want to do is you want to be able to make a first design, print it. Then what you can do is, since it's just plastic, you can get a pencil and draw on it where you want to put a different cut in or change it in any way. And then you can just get a ruler and just measure that little bit there. And then you can just transfer it immediately into here and just do a quick drawing onto this surface. So like, let's just say like, oh, I want this to come out here and it go in like that. So then I get my pencil and I draw in like that and draw in like that. And then on here, then I just measure how long this line is, how long this line is. And then I just put that in and then I just cut that out. And then it's just really easy to like edit your designs like that. I did that when I made a revodometry pod mount. I have some files on Thingiverse you can look for as revodometry mount or something like that. And so that thing worked pretty well. And I just basically made like a little square and then just marked out where I wanted all the holes essentially for the, so like I basically just measured out the encoder and then I made a little plate that had all the holes and stuff already in it. And then I put the encoder on top of that. And then I just outlined it with a pencil. And then I measured all those lines and then just extruded it upwards. And it fits the encoder really well. And so that's like something really easily that you can do. And another thing is that you can use this kind of CAD or whatever for making spacers that you need, or like a pulley. Like for our chassis, we made a custom chassis, and so I actually had to make a couple of different spacers for it. And basically, those spacers just allowed it to just be spaced exactly where we wanted it to be. And it just makes it a whole lot easier when you 3D print things, because you just make it basically what you want it to be. All right, let's see here.
Yeah, well, I'll jump in here for just a second.
Okay.
One of the things I hope that you folks are realizing this is when a lot of teams talk about CAD, they get really intimidated because they're like, oh my gosh, it's going to be so complicated. We don't know what we're doing. I know I feel that way about CAD sometimes, where I'm like, oh my gosh, what is this? But really, if you can do a lot of basic shapes, so squares, circles, hexagons, it's amazing how much mileage you can get from very basic shapes in CAD, and how that can really help customize what you're looking for. So don't think that you have to run to the most fancy or complicated designs all at once. Start with something simple. Start with squares and circles, or rectangles and circles. And it's quite effective for a lot of these things.
Yeah, something else is that with these with this wobble grabber here that I made, it started out really simple. I mean, you saw the first version. I basically just made like a square with a little cutout, like these two little cutouts, and then that right there, I just went back to our team, just tested out everything with the wobble and servo, and then I'm like, okay, these are the changes I need to do. And then from there, I just basically built off of it. And that's one of the keys with doing something like this, is that you want to just build off of it. You don't want to make something that's really complicated from the start. You want to start simple, then make it complicated. Essentially what you want to do. And so that's basically what I did, and it works really well. And another thing is that you do want to get the right filament, and you do want the right infill and all the other print settings. And one of the downsides of 3D printing or whatever is that not all teams can do this. Like if you don't have a 3D printer, it's going to be really expensive to get this kind of a part if you order it from a company. Because if you order it from a company, this piece here could be like anywhere from like $15 to like $30 for them to print it for you. And that's just like one of the things that a lot of companies do, is that they overprice a lot of their 3D printing businesses or whatever.
So let me kind of stop you here real quick, because I don't know if you heard about some of the things that we've got, but for teams that don't have 3D printers, number one, you're surrounded with teams that do. So
yeah, for sure.
Feel free to partner with other teams in FTC. Also, I believe Laurel mentioned, yes, that there was a makerspace in Salt Lake that was essentially allowing us to use their 3D printers for free. Was that right, Laurel?
I believe so. I do not know if they would charge just a little bit for the forgive me, the plastic, which I know is not called plastic.
The filament, yeah.
The filament. We can double check on that. But one thing just to remind everyone is they will have a complete competition set at that makerspace for all of you to use. So if you do not have your own, there will be one available to you.
Yep.
Okay.
So yeah, that's a good thing to point out is if you don't have a 3D printer in house, which by the way, you know, you can get the Travis, why don't you talk about real quick what 3D printer you use and how
Okay.
much it cost you?
Yeah, so the 3D printer that I use is a Creality Ender 3. They're really nice because they're a really nice DIY platform. You build most of the printer yourself, and then so it's like really cheap that way because it's not a pre-built one. And it's really easy to find parts since it is a DIY printer, and it's been around for quite a while now. And so finding parts and stuff like that and upgrades for it is like really easy. They're not too bad per se. And this printer that I have right now, it's like $160, which is like absolutely like nothing for a printer. I know on Amazon there are a couple cheaper ones, but they're not quite as good because they're like these little micro printers or whatever. But mine is like pretty big. It's basically like 9 inches by 7 inches by 7 inches for its build space or like printing space or whatever. And it's just like a really easy platform to use, which is nice. And yeah, I've put in some upgrades into it or whatever, but hasn't been anything like too crazy per se. But yeah, getting a printer like the Ender 3, I would suggest it. It's a pretty nice option to get.
Yeah, I mean that's the thing is you can get that for well under $200, and you know it's I would recommend it as a worthwhile investment. But again, if you don't want, if each team is different in its own resources and needs, there are other ways to get access to 3D printing without having to own a 3D printer, and we want to make sure that you folks know that. Oh, and Laurel mentions that the SUU makerspace is open to those, particularly in Southern Utah. Okay. So Travis, why don't you go ahead and grab the robot and let's do some practical demos or show off the exact thing. So while Travis is getting the robot set up here, do you folks have any questions on anything that we've gone over with the system here? So just so you're aware, while Travis is getting set up, this system was built with the wobble goal grabber in mind. Oh, another thing from the chat. Can probably make some friends in Southern Utah area and send them the print files. Yeah, we could do that too. So yeah, there is no limit to how you can get around certain challenges without having to have all the money and things in-house. And that goes for other technologies other than 3D printing, things like laser cutting, for example, or even something even more advanced like a CNC. There's a makerspace here in Provo that does CNC as well if you want to do something really fancy. There's more options than what you might think, even if you're not associated with a school or if you don't have a big shop. There are places where you could go. Okay, so I see the robot is going.
Yeah, so we've changed out our chassis a little bit now. So now it uses chain to drive the wheels, and the motors are located in the center of the chassis. And now it's 1-to-1 gear ratio, whereas the stock GoBuilda kit was like a 2-to-1. So it's a lot faster now, which is nice. Anyways, so I guess I'll just show off the this grabber here. So just grab a skystone like that and just drive around or whatever.
So this is an example of a passive intake, which we'll talk about passive and active intakes later on in this workshop.
Yeah, so it's like really easy to do that. Hold it really well when you're driving around. It is a little bit harder to get right, especially when you have a faster robot or whatever. But yeah, it's pretty nice. Grabs it really well. You can move around a lot like that. It's not going to come out. So yeah, that's one of the nice things about it. And here's our wobble grabber.
Travis, is there a way you could zoom in a little bit more on the mechanism of the lift mechanism on that robot as you lift up that, just so that folks can
Yeah,
see?
might be able just to bring it closer, I guess.
Yeah.
Because I'm using a webcam here. It's on a tripod, so.
Yeah, if you could just bring that a bit closer so you
Yeah.
can see the stringing.
I don't know how well you can see it, but
Is that on like a laptop or is it on a computer?
it's on the webcam.
Webcam. Okay.
Yeah.
And the
Might be able
webcam is
to-
hard mounted. You can't pick it up and move it.
I can move
There.
it, guess. Yeah. All right.
Okay, yeah,
so,
there we go. That's better.
Yeah. It's that. And then press this button. So this is basically like a cascading slide here. So that's it, like fully
The
extended.
stringing, just to make sure that there's no confusion, this is a continuous rigging, not necessarily cascading rigging, which we'll get to the difference between those a little later on. But yeah.
But yeah, anyways, but yeah, it's pretty nice. It goes up pretty high, which was nice with the, like with this, you only needed 2 slides to get over the wall, like the official competition wall or whatever, which was really nice to just do it really quickly and nice and easy. And yeah, it was a very reliable system. So there's our pulley and stuff there, and motor and cord management or whatever. And yeah. Anything else you want to add, Piefler? Or show?
So this is a pretty simple system. This is just a continuous loop that uses gravity to go back down. There are other ways to pull the slides back down, which we'll get to when we get to rigging. But yeah, you can see how you can get a very effective lift with a pretty simple system like this. And even though we're using the long robotics system with this works for the Rev system, this works for the GoBuilda system. A lot of the systems would be rigged very similar to this. So
anyways,
okay,
should we show anything else, or you think that's good? Just turn it over to you now.
I think that's, why don't you go ahead and show it lifting up and placing it on that little place alcove where you're putting it when I was there the other day.
Well, that's over there.
Oh, well, okay, that's fine.
Anyways,
we won't worry about that then.
Yeah, I can place it on a chair.
Okay, go ahead and place it on a chair,
Right.
just so.
Yeah. Oops. Okay, hold on, I have to get a chair now.
That's okay. While he's getting that, does anybody else have any questions on how you could put this together? So as this relates to, of course, our events, one of our events is to stack objects. So you could use something very similar to this. So you could use it to stack the sky stones, for example.
All right.
Okay.
So yeah. Anyways, and then just go like that. And then yeah, just like that.
Okay. All right. Well, thank you for the demonstration, Travis.
Yeah.
Anybody have any questions or comments for Travis before we head back to my little presentation? No? Okay, well, thanks again, Travis, because some of these things, it's helpful to see the actual robot in action, plus some of the design process, rather than talking about a lot of the theory behind it.
Yeah, for sure.
Okay. So here are some other options that you can use that are commercially available. So GoBuilda sells a kit that kind of mimics drawer slides is the best way I can tell you about it. I've seen a few teams use this. So if you happen to use GoBuilda, you could use this system. And one of the nice things about this system, from what I understand, is that you can see it has these springs on here that help keep the tension of the string to where it's supposed to be, along with helping it move up and down. So if you already have the GoBuilda system and you want something that's going to be more or less ready to use out of the box, this is a good option. The one thing I have heard from teams that have used this, though, is that for certain applications, it is heavier than the long robotic slides. So you have to keep that in mind. Also, this thing can only go up to 4 stages. So if you want to do more stages, you can use this, but you're going to have to modify it yourself. So keep that in mind. So yeah, you can buy a kit like this. Doesn't include the motor, but it also includes the spool and everything for you. And I think this version's like $100, so it is more expensive. But again, depending on what you're looking for and what the task is, it could be the right thing for you. Another very common set is the Rev Motion Kit. So Rev, as you folks know, uses the extruded aluminum, these aluminum with slots in them, and it just uses some of these plastic sliders that go in between them that allow for linear motion. So if you already have Rev extrusions, this is an option you could look at. Also, other companies that use extrusions, I think the name of the other company is Robotics, has a similar kind of system to this. One of the pros to this thing is it's a really inexpensive kit. You can get a Rev Motion kit for like under $10, I think. It's all plastic parts, really inexpensive. It's really lightweight and can be quick and effective. But one thing you need to know about the Rev motion kits before you use them, is that out of the box, this kit can have pretty high friction, which means it will get, as the Rev extrusions rub against each other, the plastic can sometimes kind of rub against the insides of the extrusion, causing that friction. It can cause it to not slide as cleanly. But there are ways to fix that. One way to fix that is to use lubricants. So you can lubricate the inside to help kind of minimize that friction. Also, there are some folks that have taken to Thingiverse and made 3D printed parts that are modified versions of the Rev motion kit. So you don't even need to buy the kit itself per se. There's some folks that have been working to make something that's 3D printed that's a bit smoother than what Rev does commercially. This is a perfectly viable system. It just realized that it's probably going to require a little bit of finagling to get it to work as effectively as it can. Anybody that uses the Rev Motion Kit want to talk about their experiences with it? Okay. But yeah, I've seen a lot of teams use this effectively. I know the Grid Skippers, which I know, they're a few years gone, rest their souls, or at least the team soul. They had their own version of a Rev Motion Kit that they 3D printed, and they actually loaned us some of the parts or they gave us a lot of their parts when that team disbanded. And, it works, but again, you're probably going to need some lubricant or something to help make it work more effectively or to slide more effectively. Okay, rack and pinions. So another way to do a lift, and this is particularly if you're looking for more power than speed, a rack and pinion can be a good option for you. The rookie team that I did, so a couple years ago, Cyber Cavaliers, when we were part of Capstone up there, we did Robotics, which had the graphite is a great dry lubricant from Macy. So thank you, Macy, for mentioning that. So you can use graphite as a great dry lubricant. Rack and pinion systems like this one. This one is designed for TECS. And essentially what a rack and pinion is the rack is this kind of linear piece that has all these teeth in it. And the pinion is a circular gear, just like the gears that we typically use. And oh yes, Macy brings up another important thing is that make sure that you need to make sure that you reapply lubricants, and it can be used to reduce between any surface to help reduce friction. So not just with lift systems, but anything where you're having high friction, you can use it. So it's a great system. I remember using graphite when I was doing Pinewood Derby back in the day. So anywho, so rack and pinion system, you've got the rack, you've got the pinion, which is hidden inside here, but it's just a little circular gear, okay, that fits into the teeth here. And it's powered by this motor that allows this to move up and down. My team, the Cyber Cavaliers, we used this for the robot hang, which might not have been the best. It worked for what we needed it to, but by the end of one of our competitions, our rack was trash because our robot was maybe a little too heavy for this particular type of system, just because this the rack and pinion that's sold by TECS is plastic and it can wear very, very quickly if you're not careful. And we were a rookie team and we wouldn't know what we're doing. So but yeah, it's really simple to use out of the box. All you do is you mount the rack to your channel, and then you put your pinion gear inside the channel, and it's really simple to set up. And it can have more power out of the box. But some things why you might not want to use a rack and pinion is that this is a slower system. You're essentially trading speed for power to a degree when you use this kind of system. So if you're trying to use a rack and pinion to, say, stack skystone blocks, for example, you're probably going to have a hard time keeping up with teams that use drawer slides. Just because this is a slower thing. However, the rack and pinion can handle heavier loads. And I wish TECS or another company had a rack and pinion that wasn't plastic. Does anyone know of any FTC rack and pinion gears that, other than the TECS system, that are available out there? Because I'm not aware of any. Okay, so it says this paired with a word game is my favorite mechanism. Macy, why don't you go ahead and unmute, if you're able to unmute. Could you talk about your experiences with this, or are you in a place where you can't unmute? I'm going to take it that you probably can't unmute right now. But Macy says in the chat, this paired with a worm gear is my favorite mechanism for good control power. You do want to have software limits. Yes, that's something that I ran into with a rookie team is one of the reasons why we stripped it is because we would go too far on it. And therefore, if it got theirs, it would strip. Macy says he recalls somewhere seeing a rack and pinion system that was made out of metal. So if anyone can find it, I don't think GoBuilda has it. I haven't seen it from Rev either. Maybe
And-
Actibotics.
Yeah, also, I mean, nice thing is that with Rack and Pinion, you could probably get them in a lot of different places.
Yeah,
Which is a nice thing. So
you could
I don't know, you
probably
just look
find them on
around.
Amazon. Yeah, you could probably find one on Amazon that might need a little modification to work for FTC, but yeah.
Another
then if you do-
option is maybe using like a lead screw drive kind of a thing, because those
We'll
things
get
are
to
also
that.
full metal, but yeah.
We'll get to that.
Okay.
So, so Macy says if you do pair it with a high-speed motor with a worm gear, you can get it to be fast as well, which is true. And then the worm gear, in his opinion, is the key for making this style work. And, you know, I think for things like robot hangs, I think this is a great system to use, just not the Tetrix version of this system. So, and by the way, adding like programming limits to this is not very difficult if you're using something. One way you could do it is you could use an encoder. You could use the motor encoder that makes it so it turns a specific amount of times. So you're making sure not to overturn in either direction. Or you could use something like a limit switch. You could use a limit switch on there that makes sure that sends a signal that says, hey, turn off, those kind of things. So there are pretty simple and effective ways that you could add to make sure that this thing doesn't grind itself to bits like mine did. So learn from our mistakes. Anyway, any other questions or comments about Rack and Pinion? And then, yeah, another one, and I like limit switches because they can't be under programmed. Yep, correct. So as a matter of fact, our team just got a couple, we just bought the Rev magnetic limit switches.
Do you want me to go get them?
Yeah, if you want to show them off, go ahead. So yeah,
Okay.
go ahead and grab, we'll show off. Yeah, our team actually went and bought limit switches, which we'll talk about that more next week when we get to sensors. So these guys, essentially, they detect that there's a magnet and they have something that detects that magnetic field. So when they detect that, you essentially mount the magnet to one side and you have the limit switch on the other. And when the limit switch detects the magnetic field, it says, okay, we're at this distance. And you can either make it say start or maybe stop, make it into a kill switch that says, hey, stop, we don't want to go any further. Okay, you got him? Yep, so yep, there's the Rev limit switch. And then just the encoder cable that goes along, or not the sensor cable. And then those are the magnets, I believe, that go along with them. Travis, we can't hear you.
Sorry, my mic's muted.
Yeah.
Basically, the nice thing about it is that you can place it on the slide like this, facing this way. And then you can mount this onto one side here at the bottom and another one at the top. And so basically it'll go up to here. So if you start here, it's like, okay, go until you get a magnetic signal. It'll come up here and then stop when it hits this magnet here. And then you can press say, hey, go down until you get a magnetic signal. It goes down, comes in contact with this, and it stops.
Yep.
So that's one nice thing about using this between this and a touch sensor. These things I think were like $12, am I right?
Yeah, they weren't bad.
Yeah, so they weren't too bad, and they are pretty nice. They're nice for using it for things that are like moving like up and down or stuff like that. It's like little systems on your robot that you might need this kind of a thing for. And they're really easy to mount and whatnot. And so, yeah.
And of course, you don't have to just use them on Rock and Pinion systems. You could use them potentially on any sort of lift system. So, and you could even, if you wanted to get real fancy, you could have it like, let's say you want for Skystone, you want to move your thing forward a specific distance. You can program it so that a touch of a button, it just goes to that distance. So a lot of great applications there. Okay. Lead screw systems. So lead screws, essentially they use a screw system that transforms that spinning motion of a motor directly into linear motion. This particular example is from GoBuilda. Okay, so essentially you attach a motor to the bottom, it spins the screw, and that screw moves this piece of, I think this is called Go Rail, up and down. Okay. So one of the nice pros about it is that it's a great system for high load applications. So if I were to go back and do Rover Ruckus again, where I'm hanging the robot, this might be something I'd look at. Okay. It's certainly not the only solution. There are plenty of other ways to do it as well. But this is a nice solution for getting, lifting up a heavier load, like say an entire robot. The nice thing about this kit is it comes ready designed for you out of the box. It's really relatively simple to build and maintain. You might want to use some lubricants, some every now and again, just to make sure that you're not stripping your screws or whatnot. Make sure that everything's running smoothly in there, or it's not seizing up, I guess, is another problem. So really, really decent system.
Also, one way to easily lubricate these kinds of things is like right where this little like golden piece is there. That's the part that is pretty much attached to the lead screw. There's going to be like 2 to 4 like grooves that are right there. And basically, if you just put some like oil or graphite right in there, and then you just move it up and down, up and down, up and down, just do that a couple times, it'll lubricate the entire rod, and that'll keep it from like anything like that. It's just really good way to lubricate it.
Yep. So some cons. So again, we're trading speed for power with this. So this can go relatively slowly. Although again, if you get a high enough speed motor, it can go fast enough for a lot of things. So while I would recommend this for like lifting the entire robot, I don't know if I'd recommend this system for like a Skystone system where you're stacking blocks. You're probably better off using a drawer slide or another kind of quicker popping system than something like this. Also, you're limited by in its reach by the length of your set screw. Now, technically, if you really wanted to, you could probably cascade them together. So you could have multiple set screws, that cascade of one on top of the other. But I don't know if I'd recommend that. I mean, you can, but I don't know if that would be my preferred way to lift light objects quickly at higher distances. But to lift heavier objects at smaller distance, this thing is ideal.
Also, building a cascading kind of lift with this is going to be really hard.
Yep.
As well, because you have to figure out how to get the power to the lead screws when they go up. That's one of the.
I guess you could chain them together. I guess I don't know. That'd be kind of.
Yeah, that's what I'm saying.
It's doable.
Like hard. Yeah, it is doable.
It's certainly doable, but it would be more complicated, perhaps, than what it's worth. So, anyone want to talk about their experiences with using lead screws? Okay. Now this is a new one. I've actually not seen any teams use this, so I'm not sure how great of a system this is yet, because this is fairly new. So GoBuilda has a kit that actually uses servo power instead of motor, a straight up motor, to transform that spinning motion of a continuous servo into linear motion. It's not going to have the same kind of torque as, a full-on motor, but for some applications, one idea that popped into my mind when I saw this is one of the, there's essentially two motions with Skystone, right? You've got the up and down motion, but a lot of teams also added like a front back motion. So they were able to put the block over the foundation. So they were able to stack it in the same place. And I look at something like this, and I think this would be good for something like that, because you're not mounting a heavier motor higher up, because the higher up you mount something, number one, you have to lift it. It's more weight that way. It's also less stable. It's going to be more it's going to tend to tip if you're not mounting it carefully. Whereas a servo is much lighter. And can move this into a different system. So I think this has some very good specific applications. I wouldn't trust this to lift the robot though. But that's, again, part of this workshop is just making sure you're aware of what systems are out there. And
Also,
so I thought I'd give this a mention.
With this kind of system as well, there's a lot of files on Thingiverse for this sort of thing. So it might be a better idea just to like hop on a Thingiverse and maybe just like find one of these kinds of files. Since it's probably not going to be doing too much weight or whatever. And just simple 3D print and have it done. So, because there's a lot of things on Thingiverse are for servos and whatnot. And so it shouldn't be too bad of a deal to find one that's easy to build and would work for your needs.
And it'll probably be less expensive than this. So again, lots and lots and lots of options out there. Okay, so how you string up your lift system, and this goes for multiple different types, for the drawer slides or the rev system. There are many ways that you could rig this. And again, depending on the exact thing that you want your lift to be able to do, some systems may be better than others for your particular need. So the simplest kind of rigging is called a continuous loop, which, by the way, the robot that Travis showed you folks, that used a continual loop system. Okay, so continuous loop uses one long loop of string, or technically you could do two strings. You could have one string here and a second string there, that's used to connect all the stages. Okay. Now, this red string, of course, is the one that you need to make it extend. The yellow string is your retraction string. This guy is optional depending on what exactly you need your lift system to do. You can actually not have a retraction string and use gravity to have your slides go back down if you want to. Okay, if you have a heavy enough system that can work. Or if you'd rather have it powered both ways, both up and down, you can string it this way. Now, be aware that your motor needs some sort of spool on it that allows it to both wind and unwind without getting tangled, because, oh my gosh, getting these things tangled is a nightmare, particularly in the middle of a competition and trying to get untangled. I'm speaking from experience, not with our team, but with other things. But yeah, it's a pain. So make sure to design your ropes or strings in mind so they don't get tangled. So yeah, very, very simple. You can see that there's just a series of pulleys that alternate from the top and bottom of each stage that attach to whatever it is you're lifting. So it's a very, very simple system. Why is that not? It's clicking and it wasn't moving forward. There we go. Okay. Even though this string's for a continuous loop, you can use a separate string if you want for the second one. an important thing to note when doing any sort of system like this is that the string stretches over time, okay? Which means that you can have something that's really tight to begin with, and you're like, oh my gosh, this is great because it's so tight. But then it can introduce play and slackness into your system as the string or whatever you're using stretches over the time. It is therefore a good idea to stretch whatever string you're using out before breaking it, before you get to competition time. And of course, you need to make sure that you have spare strings, because you don't know, things can break. Things have broken. It's not if, it's when. One thing to be aware of with continuous loop, if you watched Travis's robot, it lifted up one stage at a time, starting with the lower stages, and then did the upper stage last. So it can be a bit slower than stringing it in a cascade system, which we'll show you in just a bit. But if you want something that's nice and simple, and really for the wobble goal lift and ultimate goal, you had 30 seconds to get that wobble goal over the thing. You had plenty of time. There really wasn't too much of a need to do a cascading loop or a cascading system. So for things like lifting up the wobble goal, continuous loop works just fine because it doesn't need to go that fast. Plus, it takes you can use a lower torque motor on this than you would for a cascading loop, which we'll get to in a moment. Any questions about continuous loop rigging? Anybody used continuous loop before? Other than Travis, of course. You should. Okay. The other way you can string this is by using what's called a cascading system. So you can see on the cascading system, there are separate strings for each stage. So you have one attached to the motor that goes to the first stage, goes on a loop on the stage that doesn't move, and then attaches to the bottom of the first stage. And then you have a separate one that attaches from here to here. So you have separate strings for each stage that you're moving up. The advantage to using a cascade system is a cascade system will move all stages up at once rather than waiting for each stage to fully extend and go to the next one before lifting the next one. You'll notice for a lot of the Skystone robots, a lot of the top team lift systems were cascade because it allowed them to lift the entire robot to the very top in a very short amount of time. So that's one reason why you might consider using a cascade system rather than a continuous loop system. However, because your robot is lifting all of the stages at once rather than one stage at a time, you are going to need some higher torque on your motor. So so keep that in mind. If you decide to do it this way, you need to make sure to have a bit more torque because it is lifting the entire thing at once rather than one stage at a time. Now, how you retract a cascade retraction can depend on what kind of things that you have. So one way to retract, and again, you can rely on gravity if you want. If your system is heavy enough, you can just use gravity. But on a horizontal lift system, you can't. So you have to think about this for that as well. So cascading lifts can be designed in multiple ways. One is you can use what's called a continuous return. And by the way, all this information is based off of things from Game Manual 0. So if you want to revisit any of these things at any later time, you can go to Game Manual 0, and they have excellent resources talking about all these different ways to string it. But anyway, continuous return, you just use a single string to go back to your motor. But one thing a lot of teams don't realize when they're doing a cascading system is they make the mistake of making their continuous return spool the same size as their extension spool, and you can't do that. What you have to do is you have to increase the diameter of your return spool by n times, n being the number of stages. So if you have a 3-stage lift, that means that your return spool has to have 3 times the diameter of your original spool. Okay, and that has to do with the way that the cascade and continuous interact with each other. So you need to be aware of that. So if you have a lot of stages, you might need a very big continuous return spool. So that might not be the optimal way to string it in its returning. A second way to do it, I believe Travis mentioned this, is you can stick a piece of elastic on the bottom of your last stage that kind of pulls it back, so it kind of supplements gravity. So you could use something like surgical tubing that pulls the stages back down. It can either help gravity that way, and it essentially just, whenever there's no power to the motor, it just helps pull the whole system back down. However, that means that your motor, when you're extending up, is going to have to fight against that surgical tubing. So that means that your motor is going to need even more torque. And what happens if that bit of surgical tubing breaks? Could your robot imagine if your lift gets stuck? Yeah, no good, right? Game Manual 0 actually does not recommend using elastic retraction for those reasons. But there are teams that have been able to make it work. So, just make sure that you find something that works for your team. The third and more complicated way is you string it with cascade both up and down. I don't know how well you can see this, but you can. But the red is the extension string and the yellow is the retraction string. And you essentially string them so they're both in cascade. So it's powered in both directions. And you don't have to have the different size retraction pulley. You can just use the same pulley for both sides. So it has that benefit. It allows you to extend and retract it from both stages. The thing is, though, you're doubling the number of strings. So for the cascade up, you're going to use 3 strings. Well, you also need to use 3 strings to go down. And that just introduces more strings equals more failure points, more places where this can go wrong, and making sure that you're tensioning at every single one of these points. So it can be a bit of a pain. But if you want something that goes up and down very, very quickly, and you want a stringing that'll help you do that without having to have this massive return spool, this is one way to solve that problem. So these are some different ways that you can string your lifts without, and without having to rely on gravity. Okay, what string should you use? Don't use kite string. Kite string's not strong enough. Okay, it will break. Some teams have used fishing wire. Now, you need to make sure that you're using strong enough fishing wire. And if you use single core fishing wire, one thing that you need to be aware of is that if that fishing wire gets nicked, and I've seen this happen, even though you have like 100-pound test on it, it can break at lower loads just because it can, if you introduce any sort of nick into it, it can easily break. So that's something you have to be careful with, particularly if you have that fishing wire rubbing it up against anything that's metal. However, if you want to use a braided fishing wire, those work pretty well from what I've heard. So they're braided higher higher test fishing wires that work pretty well. Our team this year used paracord, which, as Travis mentioned, that worked pretty well for us. It doesn't stretch as much as some of the other options, and it's fairly strong for it's a pretty good bang for your buck. Now, if you want to get really fancy, you can use Kevlar. There are Kevlar rope, strings out there that are really, really strong, but you're paying for it. So
Also, the rev cord that I suggested in my slideshow, that's also like a paracord sort of a thing. And
right.
so I imagine that it'll work quite well as well.
Yep. So deciding how much you want to spend on it, based off of what you're using it for. But yeah, paracord you can get. I got our teams at Hobby Lobby. So, but I'm sure you could get it on Amazon or any number of other places. So that's the end of kind of talking about linear lift systems. Has this been helpful for you folks to give you some ideas on what's out there and what kind of things that you want to use? Okay, I see a yes popping up. That's good. Yes, good. I'm glad to hear that. Yes. Because that's the thing is, before putting together this thing and reading through Game Manual 0, I didn't know about all these systems before I did the research on this. So it's good to know what's available out there. Each team can pick what bar, and this is just going to be, we're playing on a 1-inch bar. And the robot can lift itself up the largest distance from the ground. So the way we're measuring it is not how far the tallest part or the top part of the robot's going, but it's how far off the ground the lowest part of the robot gets off of the ground. That's where we'll be measuring. And as far as how long it needs to stay off the ground, it needs to stay long enough off the ground so the referees can measure. So it doesn't need to be a long amount of time, but it does need to be long enough that we can get an accurate measurement of how far you are off the ground. So be aware of that. Now, make sure that as you're doing the robot pull-up, now, I don't know how heavy your robots are going to be. Make sure that you have a system that can handle the torque and the forces required. Because the last thing you want to have happen is to use a system that's going to bend or something as you lift. So be careful of that. Any questions about the robot pull-up? Okay. The last event is the tower build, which is essentially mini Skystone. To reiterate, you're just going to have the blocks already laid out for you on your side of the field, and your bot will just simply pick up and stack as high of a tower as possible in 2 minutes. Now, one thing that we discussed a couple of weeks ago is, can you handle more than one block at a time? And we're going to say yes, you can. But when the blocks are all laid out in the area beforehand, it'll be a single layer. There won't be pre-stacked for you. So if you're going to pick up multiple blocks at a time, you've got to have a mechanism that can do that. And then if you use all the blocks and you build the same size tower, time will be used as a time breaker. So whichever team can do it the fastest. A couple of things with this, and I think this is kind of where we're going to, this is the last major topic we'll talk about today, and then we'll let you folks strategize as alliances. One of the things that you're going to want to talk about is, how are you going to intake the blocks? Are you going to use a passive intake like a claw, like what Travis demonstrated earlier today? Or do you want to use, a lot of teams during the Skystone year used wheeled intakes to bring in the block into a middle area? and that allowed it to grab the blocks in a predetermined way. So it was consistent every time. Because one of the big downsides to using a claw, now let's go advantages, disadvantages. An advantage to a claw like this is that they're really easy to build, they're easy to maintain, but it takes a bit more skill as a driver than an intake does. Because an intake, you kind of run into it as long as you've built your intake well, and it moves the block into where it needs to be almost automatically. Whereas if you're depending upon an external claw or a passive intake system, your driver needs to have enough practice to be able to pick up the block in the right orientation and be able to stack them. That's one of the reasons why a lot of teams would use a more active intake. Not only it takes some stress off of the driver, and it also makes it so that you can be a bit more consistent with each block, as long as you're building it properly.
Also, does the robot have to fit inside an 18 by 18 by 18?
Correct,
Okay.
It does. Yep, that is for all events. They need to be able to at least start in the 18 by 18 by 18 cube. The only other thing with intakes I want to show you folks, I'm going to go ahead and pull this up on here so you can see it. The active intake. With active intakes, you're going to want to have a dedicated motor for it. Some teams have gotten away with active intakes with servos, but you usually want a bit more power with those. Now, with the Skystone style intake, I'm going to pull up a picture here so you can get an idea of what kind of intakes were available. Yeah, that's a. Go ahead and share my screen here. And common intakes for Skystone involved these green compliant wheels from Andy Mark. You see those, a lot of teams use them this year as well for Ultimate Goal. Very, very common type of intake. You could probably also use the newer Go Build a Gecko wheels for this as well if you have those. And the idea is you just have a motor that runs them in and that intakes them into either a set place in there, or a lot of Skystone robots had a space in the middle of their robot, kind of like this, where they would intake it into the middle part of the robot where it could be picked up and moved. As I recall, teams like the High Voltage Couch Bananas and Checkmate had robots like that. Do you necessarily want to do it for this challenge? That's up to you. If you feel like you can do it, everything that you need to with a claw and build it that way, as long as you get enough practice, that should work just fine for what you're doing. But maybe you want to try something a little more tricky. Also, you might want to start thinking, even though this isn't necessarily for this year's camp, but I'm glad this picture's on here. One of the things that we already know about next year's game, about Freight Frenzy, is that we're using the balls and cubes again. So you might want to look at Rover Ruckus. Now, none of us know exactly what we're going to be doing with the balls and cubes, and we do know the cubes specifically are being modified somehow. First has not told us how. It might be as simple as putting a sticker on the side, and it might be complex, like, maybe stringing a few of them together. Who knows? We don't know yet. But you might want to start looking at intake systems from previous years and looking at how you might be able to apply them to this year. you probably don't want to get too far down the design and build stage that you build the whole thing and then the game's revealed. It's like, oh crud, that system's not going to work. But it can't hurt to have at least some ideas in mind before you get to September. Okay, well, that's about all I have for you folks for this afternoon. I just wanted to mention all that and give you folks some time to ask questions or make comments. So any questions about anything with the camp, anything we've talked about today, anything at all, really? Anybody have any questions? All right. Well, in that case, again, if you guys have any questions that you come up with anytime during the next few weeks, ping me on the Discord. I'll be happy to answer them for you. So the rest of today, Blue Alliance, you're in pretty good shape, although I would recommend touching base with the rest of your Alliance teams to make sure that everybody is on track. Maybe give some progress reports to each other about what you're doing and how far each team has gotten on their robots. Maybe bounce some ideas off of each other, particularly on things. And if you guys need materials, talk about what kind of materials you might be able to share with one another. Please let us know if you have any questions. So now we're going to, I think we'll go ahead and end the Zoom part of this meeting. So everybody will head off or hop off of Zoom, and we'll all head over to the Discord. And if you want to do video or voice chat over there or just text, that works just fine.